afternoon.
Good afternoon, Mateusz. So, thank you for joining us. Okay, by now, I already provide links to recordings for topic 5 and 6. I hope you and all your colleagues have ability to download and view that recording.
Okay,
So,
thank you very much.
Please check general chat on this class. Here I have just placed that recordings. So here should be those recordings. You have to see my screen right.
Topic 5.
5 and 6.
And 6. Yes, I see. Okay. in general chat.
Right now, I will provide some specific points and other explanations and demonstration on topic 7, which is also dedicated for today. So let me switch to Moodle, because every time our major source of information will be Moodle. And back to course. Topic 7, consider questions related to one of approach for making scientific grounded decision by performing hypothesis testing, statistical hypothesis testing. So, as usually, please check practical class material first. It provides all necessary materials. What is important that this document repeat initial topics from topic 5 about descriptive statistics, because hypothesis testing every time based on top of it, and extend it with extra points, which is theoretical points, which is related to hypothesis testing. After we evaluate type of distribution of our numerical data, we can proceed with hypothesis testing, and here given necessary background about kind of hypothesis testing and about steps for hypothesis testing. Pay specific attention for the table on page 13. It's provide like simplified algorithm how to choose proper hypothesis testing method. So table have to be processed from left to right. In left column, you are given actually classes of practical tasks. So you have to compare those tasks with your real task you were given and find out which one is most similar. Second column from left give for you then appropriate statistical hypothesis testing method from statistical viewpoint, like statistical tasks. So that's all things actually I had explained it in lecture today, so also in lecture available recordings, and I strongly recommend to check also lecture recording, actually 2 recordings there, but fast recording, only related to hypothesis testing. Let me get. Third column represent necessary condition. Usually it's evaluation of distribution type. So we have to just make choice between parametrical tests for normal, if data distributed according to normal distribution, and non-parametric tests for other kind of the distribution or for nominal data. And last column give us exact method which will be correct in your circumstances. Why such complication? Because as you can see from last right column, we have number of methods for test hypothesis, and each one of those methods have strict limitation when and how it has to be used. So we have follow this algorithm to pass into exactly single cell at right side, which give us correct method for the current time. All these points here provided. Also here we have on the states of hypothesis, you have proposed like templates how to fill this. In gaps must be given a name of statistical parameters like independent sample mean. And also it has to be extended with practical meanings, which is probably most tricky part because it has to explain the relationship between statistical parameters and real world object. Third section of this document, it's actually a small, not statistical textbook, but like even small section from textbook, which refer and explain most common useful statistical criteria, like compare population mean to sample mean, compare independent sample mean, and so on. So here provide necessary minimal, not all, but minimal necessary statistical theory. Of course, if you need, usually it will be necessary to know more, so you have to use actually almost any statistical textbook, because it's actually have primary importance in this task. And on the chapter 4, give an example how to make this calculation. It's again start from descriptive statistics. So again, remind topic 5. Then given some introduction for non-parametric methods, like how to calculate ranking percentiles. Of course, it's specific for spreadsheet. If you would use any special software, it might be much more easy and quickly. But like spreadsheet are labeled everywhere, and for example, statistics are not exactly everywhere. And on the 4.3 section, starting from page 21, given some notes about how to make statistical hypothesis testing. An additional section given about how to conduct analysis of variances and so on. What is most important for you is chapter 5, which is provide you with example. So here we have some numerical data, some scientific question to be which is asked and have to be provided scientifical answer, scientifical grounded answer with scientifical evidence, with statistical evidence, backed by statistical evidence. And here considered steps how to solve it. Those steps are almost exactly like you have to do, except maybe numbers and indexes slightly altered. So right now, please let me show you. Okay, you have to complete one of given example, one of given task by variance. Variance again given in chart, like order 1, 2, 3, 4. For each task, you are given description of some like research case or clinical case. And you have already predefined question about hypothesis, about real world hypothesis, then numerical data. And then you are given 7 questions, 7 steps that you have to complete and provide answer. Attention, question 1 is completely theoretical. Question 2, actually only practical. You have to calculate those parameters. Question 3 and 4, also only theoretical. So you just write down your answer for 1, for 3, 4, 5 could require both calculation and explanation. 6 and 7, actually you can provide even single answer calculation. 6 only calculation. 7 explanation of 6, explanation of results you obtain in 6. So 2 and 6 only calculation. 1, 3, 4, and 7 only explanation, and 5 might contain both, but not all variants will contain it. It's actually all variants pretty similar, except some. Every time, please pay attention for question how it has been formulated. Actually, it's really almost nothing to show practically, because all things already presented, how to make calculation, already presented in topic 5. You have to make same calculation like descriptive statistics. Let me get back to example of topic 5 I have already provided. So here is we have. Let me add the hemoglobin. Let me see, that will be for male. Female. So let me analyze, compare data from B to E column. I need to imagine this data. Something like this one. Okay, something like this. Let me compare and answer like same question, like an example. Does available any difference between these both parameters for different gender, male and female? So at the first stage, we have to calculate descriptive statistics. We already done it, except I will extend those formulas to one more column to have the same descriptive statistics for other group. And actually I need one more time calculate descriptive full descriptive statistics, because I need skewness kurtosis, this two value. I have it for hemoglobin for male, but not for female. Let me make this calculation again. Okay, Excel minor analysis toolbox start. So one more time, I want to calculate descriptive statistic. I will pick up range I need. Ensure it's correct, ensure labels. Okay, those and output range have to start from this cell. Okay. So right now I have my necessary calculation. That's pretty the same, how like for, let me maybe even remove this part, not to disturb you. But of course you can calculate by formula as well. It will be also correct, and you will provide correct result, no problem. Moreover, in fact, such as you need only mean, variance, and skewness kurtosis, only this for value. It's even could be even maybe faster to use formula. But anyway, it's almost no matter which way you will do it. So we need only this for value for this analysis right now. But if you calculate all, no problem. At this, so we can do this calculation, and then we have to start with our rating, written answer. In fact, I have omitted by now. I have omitted answer 1 and made calculation for step 2. It's possible to do this, but then I have to get back to my step 1. And such as I'm using the same data, like an example about hemoglobin erythrocyte for male and female, my statement will be like this one. So here will be my null and alternative hypothesis, these two pieces, exactly like this. Let me rename it into topic 7 now. I'll just place it in the same row. Not good. I just show this, for example. You must write on your own, of course. It's like example how we can provide this. Technical example. What should contain this statement? So first of all, we have to please check this part, bottom part of page 26 and top part of page 27. It's explain again how to use table on page 13. Again, in our case, we compare. We have two samples. We have two groups of observation, one for male and for female. So we consider it compare control and experimental sample. Be careful because some variants represent a task like compare data before and after experiment. Be careful and think wisely. So second column give me statistical approach, statistical task compared to independent sample mean. And here in example, it has been rewritten. Null hypothesis we usually classify like there is no difference between parameters. And it sounds exactly this way. No statistical meaningful difference between control sample mean and experimental sample mean. Here. First of all, we are talking about statistical part. And so here is both represent one general population and only minor variation available between them, which is caused by individual features of each person. So practical meaning, we have to explain practical meaning. As there is no difference in sample mean, we have to conclusion that hemoglobin did not depend to gender. Did not depend to gender. Alternative hypothesis. Same way, we stated there is present statistically meaningful difference between control sample mean. We don't know which one is true, but we prepare both concurrent alternative samples, alternative hypothesis, sorry. So we state there that there is present significant difference, and it means that samples will represent two different general populations. Practically, it will mean that answer will be yes for our question. Concentration depend to gender. To move forward, according table, I have to verify distribution type. So simplest way to do it is to use skewness kurtosis. Bottom part of page 27 explain how to do it. You just check your value here, not range, but sorry, not range, but skewness kurtosis. You just check those pair of value. Here and here, and compare those values to critical. Critical given at the last page of practical class material. Here we have sample size we are given. In my case, it's 5. In your case, it will be different. So there is no 5, but only 7 size. No problem. I will take 7. You can take a greater value. Then skewness has to be less than given value by absolute meanings, plus, no matter plus minus. We take module value, we take absolute value. And kurtosis must be between in this range. Let's take a look. Okay, skewness, both pass condition. pose pass, pose skewness are okay. Kurtosis, okay, this one pass condition. So this distribution definitely, this sample definitely has normal distribution. Let me just, normal distribution. And here is a single value slightly outside of the range. Really outside, really, it's smaller than given low. So in these circumstances, for us, both options are available. We can try parametric or not parametric methods. That's actually a very interesting case when one sample fit normal distribution and second not exactly. Like one parameters fit, second not. Generally, if we, in this case, we still, like 3 or 4 checks, we still allow it to proceed and consider this like a normal distribution. Almost ND, but under some doubts. Anyway, we will proceed it like it's normal. So you have to write down this conclusion there, exactly how it's given. It's page 27. This way. Then we again follow this test. We have to evaluate variance. That's only for this class of task. For second class, there is no such test. Okay, we will check variance by using Fisher test. I will use again minor analysis toolpack, Fisher test. Here is important to know that we have to process data in such a way. We have to first select a sample with larger variance, no matter what is real order. Okay, in our case, larger variance is hemoglobin for male. Good, it's normal order. But even if order backward, it's no matter. You must follow that way. So here is we have one variable, then I'm selecting second variable. You see the changed. Oh, let me show wrong. I want to pick up a header. One, select two, click second time to get another input. An output range, again, I will start from this cell. Again, pick cell, click back. So here is this. What I have to use, Fisher test and F critical to tail it. Okay, we have F value, F less than F critical. So we are talking that variance is equal. But P greater than 0.5. Result is insignificant. Actually, we do not have enough evidence that it's really true. So we can proceed with a formula, with actually both. We can proceed with a formula for as equal as unequal test statistics. Okay, I will assume variant for unequal variances, then. Why? Again, this conclusion I have just provided explain it at the bottom of page 28. Check this. And because of this result, we will use test statistics for unequal variance. Why test statistics? Let me back again to that table. So sum up. We have compare conservative sample. We use independent sample means statistical test. We have normal distribution almost. Our variance is probably not equal. It would be fine to use approach without variance test, but it's not available in bare Excel and bare Google spreadsheet. You need extra extension or something like this. So I will just use this test because it's built in, which is, we have enough evidence to do this. Okay. If we're not sure that variances are equal, we have to use tests for unequal variance. It's actually simple math. Unequal variances. Okay, clean this. So I select again my input variable. Here, this case would be better to look where is greatest mean, but in this case, it's also for male. So I select second range. I have labels in first column, and my output range will be starting from there. Oh, sorry. I forget click and I almost destroy all my data. Okay, so here is, I have this. Let me this conclusion place there. So here is conclusion for F-test. So for test statistics, we are also looking for two-tailed test, this part of the table. So here is, I will check what is important. Here is, we will take a look about test statistics and this pair. Two-tailed test, because we are asking about, is it parameters equal, does not equal. Again, what is important, it's impossible to directly compare arithmetically mean. Same with variance, because we are talking about probability. We have not all data set, we have not only general population, we have only sample. But even in case general population, it's could retrieve more members, so we never sure that we deal with all data. In this case, we can't compare that numbers arithmetically. We use these methods. So here, test statistics is again less than critical to tailed. Less than critical to tailed. So means statistically equal. But again, we have case when P significance greater 0.005. Result is insignificant. Unfortunately, it's happened quite often in real scientific research. It's not mistake. It just means that your assumption nor correct nor wrong. We just does not have enough evidence. Of course, in your well-prepared variants, you will have more strong result. But here is we have this. In our case, we can talk that hemoglobin depend together or does not depend. We just don't have evidence for this. And if I have to write my article, I just have to present this result and conclusion, and it will be conclusion. We does not have enough evidence to make our statement. But in example, things much better, and they provide conclusion. Reject null in favor of the alternative hypothesis, because they have more data. So here is also demonstrate critical weakness on statistics. It's work not very good if we have a very small sample. Really, we need to have larger sample, as large as possible. So more data, so better precision we will have. It's actually a demonstration of how to make this calculation with brief notes about how to describe it. That's all. That's all. Important final points. Okay, let me stop recording.